So in this video we're going to use double and half angle identities to calculate values for sine, cosine, and tangent. And these are going to be typical drill and girl type homework problems that you would get, for example, if you were using an online homework platform or in a textbook section where they give you a lot of problems to practice. So this says find sine of 2 theta, cosine 2 theta, and tangent of 2 theta if cosine theta equals -4/5 and theta terminates in quadrant 2. So we've got different choices for cosine of 2 theta. We have only one choice for sine and tangent of theta. Clearly we're going to need to know both the value for cosine theta, the value for sine theta, and we're going to need possibly to know the value of tangent of theta, although when we get there we'll see that we don't in this case really need to know that. But we definitely need to know cosine theta, sine theta, and we already know cosine theta. So first order of business is going to be to calculate the sine of theta. And we know that theta terminates in quadrant 3. So if I just sketch the situation quickly using a unit circle, I know I have some angle theta terminating in quadrant 3, and because I know the cosine, I know the x-coordinate, I do not know the y-coordinate, and I do know the radius r of this right triangle right here. So what we want to remember is that the cosine of theta on the unit circle is the x-coordinate over the radius of this right triangle that we just established. And that tells us that if we have the ratio -4/5, it tells us that x is -4 and that our radius is 5. The radius can't be negative because radius by definition is a positive real number. So we know we have a -4. And what we do is use the Pythagorean Theorem to calculate y. So we recognize that -4 squared plus y squared has to equal the radius squared by the Pythagorean Theorem. So we get 16 plus y squared equals 25. Subtract the 16 from both sides, we get y squared is 9. And then we take the square root of both sides, but in this case we need the negative square root. When we take the square root this time, we need the negative square root because in quadrant 3 the y-coordinate is a negative value. Once we have the y-coordinate, we can calculate the sine, because the sine of an angle theta, and here's our angle theta in standard position, is just the y-coordinate over the radius, and we know the radius is 5, and we already know the cosine is -4/5. And so once we have these two things in our pocket, we can go through and calculate cosine or sine. For the cosine of twice theta, I have 3 choices, and I really get to decide which of them that I'm going to use. So for example, I could choose to use this first one. It's up to me. So I could say, hey, the cosine of twice theta is going to equal the cosine squared of theta. The cosine is -4/5. The cosine squared minus the sine squared. The sine is -3/5. And then we just go through and simplify. We get 16 over 25 minus 9 over 25 is 7 over 25 for the cosine of twice theta. And the sine of twice theta is going to be equal to 2 sine theta cosine theta, so 2 times the cosine of theta, which is -4/5, times the sine of theta, which is 2 theta, sorry, which is times the sine of theta, sorry, which is -3/5. And then we just simplify. We get -4 times -3 is 12. 12 times 2 is 24. We get 24 over 25. And for the tangent function, we actually have some choices. We can do it the hard way or the easy way. I could use the double angle identity for tangent. So I would need to use this identity right here. Or I want to recognize that the tangent is the sine over the cosine, and we've already calculated the sine of 2 theta over the cosine of 2 theta. So we could just take the sine, which is 24/25, and divide it by the cosine, which we already calculated to be 7/25, and we get 25 divided by 25 is 1 because they're both in the denominator position, which will leave us numerator over numerator, so that the sine of 2 theta will be 24/7. So our second example, we want to calculate the cosine of theta over 2 and the tangent of theta over 2, so we're using half angle identities to do that. These are the two relevant half angle identities. And we're given that the tangent of theta equals -12/5 and that theta is an angle between 90 and 180 degrees. So if we just draw this situation, if we're between 90 and 180 degrees, then theta will need to be an angle in quadrant 2, because 90 degrees and 180 is here. And what we want to remember is how the tangent function's been defined. The tangent function is defined to be the ratio of y over x, which tells us if we have a -12/5, that the y is going to be a +12, because in quadrant 2 the y coordinate is positive, which means the negative's going with the x coordinate, because in quadrant 2 the x coordinates are negative. And we're going to need to know the cosine of theta, which means we're going to need to know this radius right here. And we can use the Pythagorean Theorem to do that. We know that the radius squared is going to equal the sum of the squares of the legs of that right triangle. So this is going to give us a 25 plus a 144. And this is going to be 169. And then we take the square root of both sides. We get that the radius is 13. We do the positive square root because the radius by definition is a positive real number. And then we can calculate the cosine of theta, because the cosine of theta is going to be the x coordinate divided by the radius. X over radius if we're in the xy plane. And now I can calculate the cosine of theta over 2. I'm going to need to be a hair careful. I get cosine of theta over 2 equals, and I'm going to put the plus or minus here first, but with a question mark over it, because we need to know whether to use the positive or negative square root. And we get the square root of 1 plus the cosine, which is -5/13, and it's all over a 2. All over a 2. And we need to determine the quadrant that we're in. And what we want to do is recognize theta over 2. We can actually determine that pretty easily. We have 90 degrees is less than theta is less than 180 degrees. So if we divide everything by 2, we actually discover 90 divided by 2 is 45 degrees is less than theta over 2 is less than 180 divided by 2 is 90 degrees. So theta is actually an angle between 45 and 90 degrees, which means, theta over 2 is between 45 and 90 degrees, which means it's in quadrant 1. And in quadrant 1, the cosine is positive. So we use the positive square root, and now we simplify. So we're going to make this, instead of a 1, we're going to write it in an equivalent form, 13 over 13. So we have a common denominator. We get 13 plus -5 is 8. So we get 8 over 13 divided by 2. And this is going to simplify to, there's different ways you could do this. You could recognize that the 2 is in the numerator position, so it's going to be 8 divided by 2 is 4 over 13 divided by 1 is 13, which would simplify to 2 over the square root of 13. If we don't rationalize it, we could also right here when we got our 8 over 13, have recognized that dividing by a ratio is the same as multiplying by its reciprocal. Have been another way to get at that. Either way, we get this. And if you're putting it into I think this is fine. If you're putting it into a homework platform, it's going to want to see it rationalized, like so. But I don't think that's particularly necessary. And then we can calculate the tangent. The tangent of theta over 2 using our identity says, hey, it needs to be the square root of 1 minus the cosine over 1 plus the cosine. And then we want to recognize that we need a common denominator, so this is going to be 13 over 13. And we get 13 minus a negative is 13 plus 5 is, that's going to be 18 over a 13 over. And this one also needs to be converted into an equivalent form. 13 over 13, we get 13 plus negative 5 is 8 over 13. The 13s are both in the denominator, so 13 divided by 13 is 1. We wound up being left with the ratio 18 over 8. 2 will go into both of these evenly, reducing it to 9 over 3. Sorry, 9 over 4. I'm already simplifying. And this is going to equal 3 over 2. And the other thing that I didn't mention that I needed to, we're in quadrant 1. And the tangent, because both x and y are positive in quadrant 1, the ratio y over x is positive in quadrant 1. So I didn't use the negative square root. I used the positive square root. Quadrant 1, sine, cosine, tangent are all positive values.